compressible flow, the example for normal shock wave. A normal shock wave passes through stagnant air at 16 degrees Celsius and atmospheric pressure of 82 kilopascal with a speed of 453 meter per second. Calculate the Mach number, pressure, and temperature downstream of the shock wave. Use A, the equations, and B, the gas table. So in this question, we imagine that we have a tube like this, and we flow a gas here and air, and stagnant air here. We flow it with certain velocity. In this question is 453 meter per second here, and we found that the shock wave occur. And after the shock wave, the velocity, the pressure, and then temperature, has changed. We need to calculate what is the Mach number, the pressure, and the temperature after the shock wave. We have two methods to define this value. One is from the equation and another one is from the gas table. We will show you both methods to solve this problem. So I will show you the calculation by using equation to get Mach number, pressure, and temperature. First, we need to calculate what is the Mach number at point 1. We could use this equation, Mach number equal velocity over speed of sound. We calculate speed of sound by using the equation of surd kRt here. We substitute all the values. The velocity of gas is 453 meter per second. The specific ratio of air is 1.4. The gas constant for air is 287, and we substitute the value of the temperature at point number 1 in Kelvin unit, which is 289 Kelvin. So we could get Mach number at point number 1, or Mach number before the shock wave is 1.33. Then we could calculate the Mach number 2 by using this equation. Mach number 2 square is equal to m1 square plus 5 divided by 7 Mach number 1 square minus 1. We substitute the value and we get 0.5947. Please be careful because this value is actually the value of Mach number 2 with power of 2 here. Then to get the value of Mach number at point number 2, we need to set this value and we could get 0.7712. So we could see that Mach number at point number 2 is lower compared to the Mach number at point number 1. So here, an important thing that you need to know is shock wave only occur when you exceed the Mach number 1. So mean you need to have Mach number more than 1 or at least Mach number equal to 1 to get a shock wave. Then when the shock wave occur, the energy loss occur, then it would create a lower speed after the shock wave. So please remember that velocity after the shock wave must be lower compared to the velocity before the shock wave. And before the shock wave, the Mach number is 1 or greater than 1. After the shock wave, the Mach number must less than 1. Then we could calculate the value of pressure and temperature by using this equation. You could refer equation number 16 and number 17 to solve this problem. We already know the value of Mach number 1, which is 1.33. We substitute into this equation, we could get that pressure at point number 2 here after the shock wave is 155.5 kilopascal. Same goes to this parameter to temperature. We could calculate the temperature here by using equation number 17. We substitute all the values, we could get that temperature after the shock wave we mentioned as T2 here is equal to 349.6 Kelvin. And now we would calculate the same question by using table. You could download this table from my website. Please be careful because we have two tables. One is isentropic table and another one is normal shock table. In normal shock table, again, please be careful because this table is created depends on the medium. If you want to calculate hydrogen, for example, what happened in hydrogen, you need to take normal shock wave flow for nitrogen, for example. Because we commonly use air, so in my website, I upload normal shock flow for air, which is K equal 1.4. You will have this column, M1, M2, P2 over P1, T2 over T1, and P0O2 over P01. I will show you the usage of this one later on. Then from this table, we found that first we need to calculate the value of Mach number 1. So we could get it is equal to 1.33. So the 1.33, the value of Mach number 1, Mach number equal 1.33 here is actually not listed in this table. What you need to do is you need to interpolate to get the value of Mach number 2, the value of ratio P2 over P1 and T2 over T1. I think you are capable to do this. I will explain it here a little bit. So just imagine that we have 1.33 in the between of 1.32 and 1.34 here. So you could interpolate by having, for example, 1.32 is equal to will give 0.7760 Mach number. 1.34 will give you 0.7664 Mach number, and 1.33 will give you an X value of Mach number. So you could use the interpolate of that value to get all the value of Mach number at point 2, P2 over P1, and T2 over T1. Then when you calculate that, you could find that M2 is equal 0.7712, which is equal to the our previous calculation. P2 over P1 is equal 1.897. T2 over T1 is equal 1.21. So from the ratio here, we could calculate the value of P2 if we know what is the value of P1. So to get the P2 here, we multiply 1.897 with the value of P1. We could get the value of P2 equal to 155.5 kilopascal. For temperature at point 2 here, we do the same calculation, we get 349.6 Kelvin. The three answers here is exactly the same with the answer that we get from the calculation. In tests and exam, you may use either by equation or by using the shock wave table to get your answer.